Let's see how to fix this BMW Amplifier Logic L7. In order to remove the capacitors, we need to remove the glue. Do not use hot air for it. It's a sticky glue, it's very sensitive to temperature, and it's enough just with cutting it. As you see, I can slide a knife on it and I can easily separate the capacitor. Now, if the capacitor is good, I can put it back, and let's remember this glue has a special function on it. It's to hold a vertical big device in a car that is full of vibrations and movements. So this glue, as I said, is sensitive to temperature. You can use your soldering iron. Right now I have too much temperature because I'm heating the iron to remove the capacitors. But as you see, just with touching it, the glue will melt and it looks like nothing happens there before. Capacitors are off and power transistors too. And the reason I removed everything is because I want to make a test on the power amplifying chips. And before going to it, I remove the capacitors because I also have to test them individually, and pay attention to the following picture. I make marks on each one of the capacitors so I will know where was it. The reason I did it is because if I find one of the capacitors was bad, I will be able to know where was it and to check the stage after and before to find the reason why the capacitor was bad. Sometimes the component will damage itself because we are using it, and another times it damages as a consequence of something else that is going on. So that's the reason why I make the marks, because I was expecting to find the origin of the problem all the time. Back to it, talking about these guys. Capacitors are off, power transistors are off. I release the connections for the signal input with the capacitors there, and I will make a test with the multimeter. I'm looking for the ohms test and the diode test. Everything that looks like low ohms to me is a short circuit and a damaged chip. As we can see, and it passed the visual inspection, it looks very good. And the only thing that I am able to see as a testing without power, without the speakers, is to test diodes somewhere inside of the chip. One of the advantages that I have here is because I have another chip alike, so whatever I make the test from one point to the other chip must show the same thing. So in that way I will know I don't have to replace my chips. And I will tell you guys, most of the time I saw Logic 7 systems for BMW. I didn't have to replace the chips. Sometimes I got problems because the capacitors, and most of the time related with the transistors. And when I get this kind of situation, it's not because the problem is here, it's because the problem is outside. The problem is on the speakers. And if the speaker is in short circuit, or getting in short circuit after heating, we'll get a burned power transistors and also damage in the capacitors. 6,800 microfarads in 25 volts. If we try to make a test here, 6047.48. What is a good capacitor. With the other guys, $6,400 something. Let's remember, we are expecting capacitors with plus, minus, always minus 10%, even 20% for electrolytic capacitors. 6.4. And if all of them they behave alike, we can tell in the measurement test of the capacitance they look good. Anything related with 6400 is okay with these guys. All of them they are in the tolerance, including this one that is the lower. And also we have to check the mechanical specification of the capacitor to find out if it's inflating to explode or not. Let's pay attention to the next picture. So we know all of them they are okay. Let's see the small guys. They are supposedly 10 microfarads. They look okay. These guys they are 2200 microfarads, and they are in the specification of the minus 20%. So they passed. Guys, I don't have an ESR tester for capacitors, so I have to use my own resources, and I built something alike that I will talk about it in another video to test the capacitors. In this circuit I'm using 250 kilohertz 5 volts peak to peak in DC, and I have a very fast rising and falling timing for the square wave. We'll talk about this circuit in another video. And I'm connecting now the capacitor. There is an electronic formula I apply for it, but now I will save the time with the formula, and the specification of the ESR it should be in the capacitor's data sheet. So try to get it from there. I got my specification, it's okay. What I'm going to do is a fast and furious test. I will call the cursor and I will tell the cursor to be in the upper and let's make it like this, and lower edge of the square wave. I will forget about all the noise about it. We will talk about it in another video. And now that I got the information, I will remove my first capacitor because I already made the calculations. I knew it passed, and I will apply it to the other guys to see if they are in the specification I already set up with the cursor. Next guy. It's okay. I don't have to make the calculation for all of them. I already made the calculation for the first one, and I know it passed. And the rest of the brothers, they should behave very alike. It's the same. The square wave is the same. Same thing here. Same thing. So better than to change the capacitors like crazy, it's good to know if they are good or not, and they are very good. By the way, the original capacitors, they are expensive because I know you can order from somewhere in Canada through eBay, but I am in Europe, so we have the importations tax and everything, and they will be very expensive if I ask for the original ones. Okay guys, all these my capacitors, they are good. I will do something alike for the 2200 microfarads. For the first capacitor, I will set up my cursor. I already made the calculations and I enter the data in my calculator in one Excel sheet on the computer, and it is in the specification. As I said, to save time, I will not talk about this circuit today. I'm just making a test for the capacitors and they behave alike. Let's talk about the little ones. Because they are small and compact, they will have very high specific serial resistor, as we can see here. We can see also the timing trace. Once again, center it with the cursor. I will set up for one Do you remember, guys, in the other capacitors test, they were very alike? Look at that. Now we can tell there are difference between these little two brothers. I will compare with another ones that I want to replace. And can you see the difference now? It's a lower specific resistance. I want to place this other guy. It's a little bit rusty. Sorry, I was out of the trigger level. Okay. This is a little bit bigger resistance than the other. They are same capacitor, same brand, and even this little bit is under the specification. So I will replace the little guys with these other two guys. Back to it. When you place the capacitor back, if it is not bad, what you can do is take the soldering iron in low temperature and just slide it between the glue. As I told you, it's very soft and the coefficient of melting is very low, and it will melt again, as you can see here, as the original glue from the factory. This glue is very important because the capacitor is very tall, and in the movement in the car, with the time, it will break the solder under, and we don't want that to happen. That's the reason why we use the glue. Try to save it. When I did the test in the transistors, I found out that one of them is bad. I already removed them with the hot air. So I will just pick up them. I place them just to show it to you. And let's make a test with a multimeter to see what is going on here. We have in the order pin 1, 2, and 3 gate, drain, source. If I try to make a test in this little guy, in the diode test, I have about 71 millivolts. I will try to trigger and let's see what happened. Here I have about 0.15. It's not behaving like a normal N-channel FET MOSFET transistor. The guy next to it, I have 537 millivolts. If I trigger the gate, I got 0, I got continuity. If I touch the gate with the other lead, I have again the 500 something millivolts. What I'm seeing here is the diode between the source and the drain. If I trigger the component, I close the conduction between the drain and the source. With the positive polarity in the gate is open, and here is in conduction. This guy is good, but this other little guy is not behaving in the same way. I have 70 something, 40 something millivolts in either way, and if I try to trigger it, it keeps behaving like the same. So this MOSFET is bad. Now that we found out what is the bad device, we will come back to the amplifier and talk a little bit about it. And guys, I want you to know any device in the amplifier could be bad. For this case, this specific case, this device was the bad guy in this movie. But doesn't mean that all the amplifiers that are broken in the world has the same component in the same situation. From all the components that is in the case, any one of them could be the bad guy in the movie. For this specific case, this is the one who gives me the trouble. As I said previously, any one of them could be the bad guy in your amplifier. For my case, the one who was there was the one who is bad. In my opinion, what happened here is probably there is a problem with the speaker, and just checking the speaker we will know it. We will need the rest of the car, and probably the speaker let the current to pass in high levels, like a kind of short circuit sometimes, and expose the device. Also, they are very small device, so they can burn whatever they want, because we nowadays we make things so small and so fragile that it's not the same technology with a big transistor we used to get in the 70s. In my theory, in the car the speaker must be inspected and probably change it, no one speaker, both, to get the same similarity in the noise. And what I'm going to do here, I will change the bad guy, and also I will change the other who was next to it, just to prevent a major problem. Not only the MOSFET transistors could be bad, capacitors could be bad, and also the power transistor modules that are under here that we have to remove could be the bad guy in the movie. In my case, it's not the main problem. My problem was there. As I said, anything, even from a small capacitor, can give you troubles. In this kind of BMW DG7 amplifier, we are lucky that the main chips, they don't use the VGA technology, so they are safe from getting easy broken solder. We have some devices like coils, aluminum electrolytic capacitors, and they are sensitive to voltage. And this is important to know. Sometimes in the car, when the alternator, the regulator, is bad, it can let high voltage to pass through. And capacitors like these guys, they are 25 volts sensibility. Like these ones, they are 10 volts. So any high voltage that will pass through the system can affect another devices too. So far, that's what I found. I already ordered the parts, and they are on the way, and I hope this week this thing is going to be fixed.